Alright, in our next organic chemistry video, we're going to talk about functional groups. Now, functional groups hang off the main chain of your carbons. Alright, so for example, if I have, 3 carbons in my main branch, this is going to be a propane molecule. And if I have something else besides the hydrogens, like a bromine here, or an oxygen, or a double bond to an oxygen, those are called functional groups. So functional groups hang off the main chain, or the longest chain of carbons. Alright, so let's talk about the different functional groups. First functional group we want to talk about, let's just go in order. Let's talk about the alcohols. Okay, so an alcohol functional group, it's going to have an R. Okay, remember an R means any number of carbons or hydrogens. Alright, and it's going to be a C to an OH, and then make sure you have all the other H's in there. Okay, so you can have any number, and this could be on the end or in the middle of a molecule. So because the OH, which is the alcohol group, could be on the end or middle of a molecule, you got to tell me where the location of it. All right, so if I had an example like this, there's my hydrogens that I'm not going to draw, and you guys should know them. All right, what's my longest chain of carbons? 4. That's a bute. Single bonds between the carbons, ane, and I have a OH. Okay, so that means I have to tell me the location, so it's on the second one in. So it's a 2-butanol, OL for an alcohol. All right, so wherever that alcohol is located, tell me the location and change it into OL. And you gotta look for that OH group. Another type of group is going to be called a carboxylic acid, otherwise called an organic acid. Okay, in the organic acids, how it's going to look is you're going to have any number of carbons here. It's what R represents. And you're at the end of a molecule, you're going to have a double bond to an oxygen with an OH. All right, so it's going to be at the end of a molecule. Because it's at the end of a molecule, you don't need to tell me a location with a number. So it's always going to be at the end or beginning, depends on how you look at the molecule. Don't forget your hydrogens are there. Now, here's how we name it. Still have 4, so it's a bute. Okay, single bonds, it's an ane. Now, here's a change. Because there's this group right here, this organic acid / carboxylic acid group, what you do is butanoic acid. All right, butanoic acid. The butane, single bonds. Oic acid means you have a double bond to an O and a single bond to an OH group or alcohol group. And it could be on the back or on the end or the beginning. Either one, it doesn't matter. Next one, let's talk about ethers. Ethers are going to have any number of carbons, and they're going to have a sandwiched oxygen in between them. Oops, there you go. A sandwiched oxygen. So for example, let's use our 4-carbon example like we've been doing. Here's my hydrogens. Don't forget about those. Some people forget about them. All right, and we have an oxygen in the middle of our main chain. So what we do is we name the parts to it. So on this side we have 2, and this side we have 2. So the prefix for 2 is eth. So what we have is we have a ethyl, ether, or you could combine this, because they're both ethyls, you could say diethyl ether. Okay? Here's an ethyl group, here's an ethyl group, and then ether tells me I have a sandwiched oxygen between them. And a related group to that is going to be an ester. Okay, an ester is kind of like an ether, but close, but not exactly. You have a double bond to an oxygen, you have an O, and then you have a bunch of other carbons. So remember, these R's are any number of carbons and hydrogens attached to it. So let's stick with kind of our chain that we've been working with. O, C, C. Don't forget about the hydrogens. All right, so, and we kind of name this in parts as well. The part you name first is going to be the part that has the sandwiched oxygen that's not double bonded to the oxygen. So here we have 2, so 2 is eth, so it's going to be an ethyl group. And then we have 3 here, 1, 2, 3 carbons, so it's going to be a prop. It's going to be ethyl propanoate. That tells me I have an ester. Okay, ethyl propanoate. And the last one we really need to talk about, and we'll talk about some other ones. The main one right here is going to be a ketone. Ketones are going to be any number of carbons. But you're going to have in that carbon, you're going to have a double bond to an oxygen. It could be on the end, it could be in the beginning. Okay, they're all over the place. Well, actually, this one's always going to be in the middle. Sorry, this one's always going to be in the middle. So how it looks is like this. Let's use our chain of 4 again. Let's say we have an oxygen here. Don't forget about our hydrogens. All right, we still have 4, so it's a butane ketone. And you got to tell me what it's located off of. So it's a 2-butanone because it's always going to be in the middle. Okay, 2-butanone, double bond to the second one. Remember, you can count from left or right on the molecule. And the last one we're going to talk about is an aldehyde. Okay, aldehydes are pretty simple. What you're going to have at the end of a molecule is you have a double bond to an oxygen with an H. Okay, so these are at the end of a molecule. So let's say we have our chain of 4 again. Here's our aldehyde. And what you're going to do is name our chain. So we have chain of 4, so it's a but. Okay. Then we have AN, single bonds. It's a butanol, AL for an aldehyde, sorry. Butanol, AL. So these are always going to be at the end. You don't need to tell me a number for location. So knowing those groups, you should be able to recognize them and help name them a little bit. And life should be pretty good. Let me know if you have any questions. Hope the video helped.